Our next speaker is Kathryn Kozak, and she's at a community college in Arizona, down the road from where Anuj is. She's the former president of the American Math Association of Two-Year Colleges, and the American Math Association of Two-Year Colleges is a group of heroes. These are the people who are teaching in the community college. They don't always have the same lunchroom duties that high school teachers have, but they have enormous sets of obligations and yet come through teaching very well. I was fortunate enough to go to several of their national meetings, and just hearing about all of the things they do is remarkable. And now we're listening to one who's helped lead and shape many of the programs they have. And she's going to talk about using published sources for teaching differential equations. So Kate?
So thank you so much, Brian. So as Brian said, my name is Kathryn Kozak. I teach mathematics and statistics at Coconino Community College. It's actually in Flagstaff, Arizona. So if you don't know the area, we received 2 feet of snow at the beginning of this semester. Actually, anywhere from 2 to 4 feet of snow at the beginning of the semester. Made our semester a little bit different to start with. We are north of Phoenix. We're near the Grand Canyon, and we are not the temperatures of Phoenix. So it's kind of a different place to be. We're at 7,000 feet, so we live a little differently than people in Phoenix might do. As Brian also said, I'm the immediate past president of AMATIC, which is the American Mathematical Association of Two-Year Colleges. And I've been teaching mathematics at Coconino Community College for 29 years now. So what I want to talk about is how do I find these different activities? I've been teaching differential equations for a few years now, and I found different sites for finding some of them. And I wanted to show you where some of these sites are. And the active calculus site, and this is mostly for calculus, but for introducing differential equations, they do have some differential equations pieces to where you could introduce the idea of what is quantitative behavior of it, what is Euler's method, how do you do separable equations, and even some modeling. And this is mostly things that you'd see in your Calc 2 class, but they're kind of nice ways to introduce it. These are more inquiry-based learning type classes. And then population growth and logistic equation, of course, is something else we would do. Another one is Berkeley Math has some activities. And I haven't actually used this one, but I thought it was really interesting when I was looking things up of it actually going through how do we solve a differential equation using the integrating factor method and just having the students work through this. So I do a lot of active learning in my classrooms. So I'd like things like this where it walks the students through to see how to do it. This one seems to be more of an explanation of what's happening, but then has them work through how to do those problems. And then one of my favorite ones is inquiry-oriented differential equations, which I use some of these greatly in my classes. And you actually need to sign up for this one. It is, in fact, password protected, so your students can't get into it and see what's going on.
Yeah, I want to interrupt right at this time. There's a parallel session on IODE, but of course it's all video recorded, and so shortly you can come back to the conference center and read more about it.
Yeah, so this one is one of my favorite sites to work with, so thank you, Brian, for that. And then of course my favorite site is SIMIODE's activities. So if you go into that site, you can actually look and search for the different activities to do. We just saw a discussion about diseases and how do we look at and model those. And so you've got one on Ebola, you've got some other ones that are just kind of fun toys and things. And so this site is a wonderful place, and it just changed to a new way of searching for materials, and is really, really useful for finding out what we're doing in this materials. So I really highly suggest using that. And what I want to do is kind of talk about which one of these SIMIODE activities do I actually use in my class. So first off, my first day of the semester, again, this semester was a little different because it was canceled because of the 4 feet of snow we got which we still have sitting around our yards and such. So my first day of semester was a little bit different than what I normally have, but I usually start off and I do use the differential equations, a whole box for modeling in the world. And what I loved about this is it actually does map along with these activities that are in the SIMIODE website. So I actually start off with the dash it all learning activity. The nice thing, I should have mentioned more about this textbook if you haven't had a chance to look into it. It's not that expensive for your students, which I like a lot. They just came out with a paperback version, so my students can actually purchase the paperback version, which also comes with the PDF version. So they get both pieces of it. And if they don't want to buy it right away, and it's not that expensive, like I said, I think it's like $40, $37. They can actually look at the first chapter. So they can actually, if they haven't had a chance to buy it or they're buying the paper version, they haven't received it yet, they can actually go into chapter 1 and look through the types of problems. And I really love that about it, that it gives you the ability to look into it. And you can download the first chapter, look at what's happening in it. And like I said, it goes through, and the first problem I do is following along with the textbook. I actually look at the 100-meter dash in the 2008 Olympics, which is the very first activity I have my students work in class. So that's called the dash it all. And I actually have my students work through this after I introduce the course to them. We actually go into this activity, we work through it. They actually are modeling what's happening with this. And what's wonderful about this activity is the students actually start off with looking at what are the assumptions behind that you have to make in terms of making a differential equation model. You can't just throw a model at them and just say, here, they have to actually think about what do they have to consider and what are the different forces that are acting on it. One word of caution that I've found is that most semesters, a lot of my students have had, or most of my students have had a course in physics. This semester, about half my students have received a course in physics and half of them have not. So I found that even though this walks them through, I still have to explain some of the physics for them. I have a physics background, so it's kind of convenient for me, but I have found that that's one issue right now, is that a lot of these activities are physics based and you kind of have to walk them through how to do that. So that's a great activity though. My students go through and work this out. And they usually takes a day for them to work on this activity. They work through it. They talk to each other. I actually use non-permanent vertical whiteboards that they work on so that they can talk together. This semester, actually the last 2 semesters, we've been offering this, or last 2 years, we've been offering this course in a hybrid high flex model. 3 of my students are on Zoom. The rest of my students are in person. And so luckily I have 3 students in Zoom, so they are one group that can talk to each other. I actually give them a Google Doc that they can work on together and talk about how to do the problems. And then the other students are in class and I can actually display, I have a smart board in my classroom, so I can actually display what my online students are doing on the smart board. The other students are working on the whiteboards. And so they all can kind of talk to each other and see how each other is doing, share their information, talk and work with each other. And I can walk around and see where they might need some guidance, where they might be thinking about things in a different way than I would be thinking about it, which is a wonderful thing when you notice that about your students. So that's really my first day of the semester, is going through this dash it all activity. Then for the rest of the semester, I actually have some other activities I do. The next one in the textbook is actually the inner ear drug delivery. And what I love about this one, and I'm going to go into it a little bit, is, and I'm not actually showing you the actual ones. I can go into them, but I wanted to just show you kind of what's going on with them. But this activity is wonderful because it really is the salt tank activity, but it's from a point of view of mixing drugs in the inner ear and what is happening with drugs going into the inner ear, drugs coming out of the inner ear. and how do they keep the drugs in? They have drugs going in and they have a draining piece of it. And it really is the salt tank problem, but not just the normal salt tank problem that we deal with. We actually get to see, the students can see an actual application of this salt tank, of what makes sense with it. It's a great way to introduce it. I will admit, I do actually have my students talk about this together as a big group in class. I lead them through the discussion on this one, and try to get them to see the different pieces and what's happening with this. And that's also been very useful for my students of what's going on. Another one that I love doing is the water bottle to cooling model activity. And then this one, what's wonderful is, and I think I can actually, if I can go into my Canvas shell, let me go into there real fast. Sorry, you're following me along, and I know you hate doing that, but let me just go into my Canvas shell.
Kate, can you make yours full screen? I apologize.
No, that's fine. I can do that. So this is the bolt one. This one looks like, and I want to go out of this one and go to a different one. I want to show you the other ones I do. And so it gives you a statement of kind of what is the issue, what are we doing, what's going on with this. Then it gives them a picture of what's going on with the inner ear and what are the different pieces. And then it goes through and has them think about, what would you think about with this? What would be some assumptions that we'd have to put into this? And then it actually gives you a scenario of what we're going to do with this, and then has them walk through and actually develop through these questions here, actually develop the whole model for a mixture problem, a salt tank mixture problem with rates in and rates out. And we talk about it. They make sure they pay attention to the units, and the units are very useful for this. So this is one of my favorite ones to work through and see what's going on. And like I said, this one I actually do together as a big group, because I think this one's just a little bit more difficult for the students to find. And let me go out of that one. And then, like I said, the dash it all one is also here, so I can go to that one too. I'm gonna move you. Okay, and this one, it actually gives them the data, and we get to talk about what is your initial condition. Most people think the initial condition is time is zero, and we talk about why isn't it? And the students are trying to figure out what is going on with this. This problem comes up again to where we actually get to solve this model. And again, they talk about the assumptions. So here they develop the model. And then we get into the linear models, we actually solve this exact model. And so it gives them a chance to see what's going on with that. So those are some of the ones I work through. Some of the other models I use. So I use the water cooling bottle. That one's wonderful to get them actually into the concepts again of trying to make assumptions and then solving some problems and thinking graphically about what the solutions would look like. Another one that I really love, and this is actually one that Brian always tells me he starts with, the M&M death one. And I actually like to do this one, and I modify it a little bit for my class. I actually like to do this one. Actually, I'm done with actually what is a model, and kind of this is my summary of putting it all together and having them work together through this. I actually have my students, I bring M&Ms in for my students, and my students that are online, I just tell them you need to buy yourself some M&Ms. One student forgot to buy some M&Ms, so he worked with using the coffee beans, because coffee beans are one side is one and one side is a little different, so he's able to use coffee beans. So it gave them a chance to kind of talk about how they can change some things out with that. So that's kind of one of the other nice things about doing these, is that you can kind of have your students work through this. So I do that one kind of a summary of all the first 3 chapters, putting it all together. And then I actually use this, because I've got this half the student, well, not half, but part of the students are online and part of the students are in person. I came up with, well, how do I have my students take a test on this? I didn't want to try to have my students have some of them be in person and some of them online. I'm trying to watch those students that are on Zoom And so what I ended up doing is I gave my tests a take-home test for the classes, and I used a lot of the ideas from the IOED one. So some of these from the inquiry-based learning questions, where I have my students come up and create their own differential equations and then solve their own differential equations. So they can't be cheating and talking to each other. And then I had my students go in and I gave them this modeling problem of the Newton-Watson modeling. And this is one where Watson and Sherlock Holmes come upon a body and they're trying to find out how long does the body, how long has the body been dead? So that's some of the other things I work with this, and I use this one as part of my question on my test. And I believe that really worked nicely for my students. And then I use a lot of the other ones for other pieces, and I do a lot of other activities that I've actually created for Laplace transforms and so forth. But I also use this modeling, the spring mass system, for introducing the spring mass system, and it introduces a system. Actually, I can do systems, but also introduces a second order differential equation. And again, with my students, I probably, because I have so many students who don't have any physics background, I would probably do this one more as a demonstration in class than them working on their own in individual groups. I actually do have a spring and a mass that I can bring into my classroom and have because I borrowed it from my physics department, and I bring that in and I actually show my students how it's working. And then we talk about how we come up with the equation and where it all comes to play. So that's been really a wonderful piece that I've been doing with my classes. And as I said, I've tried to create some other activities that I use that I've either modified from the inquiry-based learning or from some other pieces that I've brought in. And there are definitely more activities in the SIMIODE library that you can certainly look through. The really nice thing about the SIMIODE library, and I really love this, so that's why I keep going back to it, sorry, I gotta find the right tab here, is that you can actually filter and pick for certain ones. So if you want a differential equation that is an ODE and you want it to be a second order differential equation and you want it to be linear, then you can see what are all the different modeling scenarios that you can go through and use that would model for that. The bungee jumping is a great idea one. And again, I would probably take one of these, probably one of the harder ones or the more involved ones for my test on this for my classes as a take-home test. So it's kind of a really nice feature of these to be able to use these in your classes to introduce your students to what's going on. And then also, don't be afraid to use them in this fashion. I also do use, and I don't have these on my slides, but I also use sites. I love slopes for that's a program you can put onto your iPads that you can use to show your students how do systems of differential equations look on a slope field or just a regular slope field. And I love using the slopes package. I also use Bufton's differential equation site that you can actually graph and show them that way, because I don't expect my students to actually draw a slope field by hand. And so I love having all these tools that I use in my classes. And so these are the different tools I use to help my students really understand. My class also, because we do transfer some students to Arizona State University, Arizona State University would like the students to use MATLAB. So we do have some MATLAB activities we also do that my students work through to try to come up with some of the solutions using MATLAB. And so I have some activities that actually ASU has nicely shared with me that I'm able to use in my classes to teach them how to use MATLAB. For my online students, we use the name just went from me for some reason, but there's I keep forgetting the name, but there's an online site that you can use. It's basically a lot like MATLAB that's free for your students to use that I also have been liking to use.
Oh, Sage.
I have not used Sage.
Okay. Octave, was that the other
Octave
one?
is the one I'm using. Yes, thank you, Brian. Octave's the one I use. And it looks a lot like MATLAB. There's a couple of things I find that it doesn't do that MATLAB does do, that the student version of MATLAB also doesn't do. So I feel a little bit more confident with that idea. So we've been doing that in our classes. I actually added a few things. I'm sorry, Brian, I changed your death and immigration a little bit and added some problems where they actually use MATLAB to solve their differential equation in the end when we put it all together. So that's kind of my class of what I do and how I use the SIMIODE materials and other materials. Are there any questions?
When you say you use, what exactly do you print out something? Do they go somewhere and get the student version because there's also a teacher version, or do you just talk about it and let them go? Or?
So what I actually do is I download the student version onto my computer. I then upload it into my Google Drive and I share them individually with the different groups in Google Drive. Because I'm in person with some of my students this semester, I actually have been handing out paper versions for them because I want them up on the whiteboards and not on the computers. So I have been giving some of those paper versions, but for my online classes, and when we were in COVID, I was definitely using the online Google Docs. It's a wonderful way to save your materials. Somebody posted in the link in the chat. I will gladly share my resources for MATLAB with you. Here's my email address. If you'd like to email me, I would gladly share everything. I believe in sharing all. And I see your hand up, Lee. Sorry.
Yeah, I'm just curious because you said you had done some alterations to the M&M scenario. Are you able to utilize the LaTeX document in order to let you do some customizations, or do you just verbally tell the students what to change?
I've downloaded the doc version and I've modified the doc version. I haven't actually tried using the LaTeX version. I don't know why I haven't tried using the LaTeX version. I haven't. But I usually just modify the doc version and use that one. Or I actually put it in Google Doc and do it in Google Doc.
Oh, perfect. Perfect.
Yes.
Okay, so I'm down the hall and I'm coming to you and I go, how on earth do you get all this stuff in and do this coverage, especially given that your students are going to go down to Arizona State and have to, know something. How do you do the modeling and cover all the material? Have you?
So, well, I start off with the modeling and then we use those model examples throughout the whole semester. So we actually just solved the dash it all differential equation in class. So that was the example I used in class. And I referred to the fact that I used that, we developed that model already. We're going to do the exact same thing with the drug one when we get to that point where we're solving that differential equation. We just did one where I was doing harvesting and we developed the harvesting model. And I will also keep using these models throughout. So I've used these models, we've understood where these models come from. And then we use them as a basics for solving a lot of the differential equations we do. I will say one thing, I love the textbook. It does not, we actually are supposed to in our curriculum, and I can't remember which university tells us we have to teach this, but one of the universities says they want power series. So it's not in the textbook. So I actually have another open source textbook that I steal or borrow that material from and obviously attribute the person who wrote that one and just add those materials into my class at that point. It is, but Brian, you brought up a really good point. It is very challenging getting through all the material, but it was challenging getting through all the material when I went through it just normally. So this gives them a basics that they actually like and understand and enjoy.
Any other questions? By the way, if you are not aware of this large organization called AMATYC, A-M-A-T-Y-C, you should just look them up on the web. They have lots of rich programs. And these are your colleagues. Sometimes you're at the four-year school and you forget that there's something that's bringing you some exceptional students who are coming there after two-year programs. And leaders like Kate make it all possible. And I've been very grateful for her work and the organization's work over the years. So thank you for your talk today.
You're welcome. And can I just plug a little bit about AMATIC also on top of that, is that
Oh, yes.
AMATIC's mission is to actually to improve mathematics in the first 2 years. So even if you're at a four-year school, we are actually, if you're teaching any mathematics in the first 2 years, we are the organization for you. They're actually the math intensive ANET, which is our academic networks, where we get to talk to people who teach Calc 1, Calc 2, differential equations, linear algebra, and have conversations with them. So please think about joining our organization. And our next conference is in Omaha in November, and we would love to have you there. Thank you so much, Brian, for having this.
Yeah, the emphasis is on TY for 2 years, the first 2 years, whether it's at a separate institution or within your own institution.
Right.
And that makes it even richer for the rest of us. Thank you.